Question 10. Here is a sector AOB of a circle with center O and angle X here. The sector can form the curved surface area of a cone by joining OA to OB. So effectively, if this here and this here were joined together, that will create the curved part of the cone below. Now the significance of this is that this length OA here is basically the same as this length here, and the curve, the arc of this sector here basically becomes the circumference of this circle here. We are given the height of the cone, we are given the volume of the cone. We do not know what the radius of this circle is, and we do not know what the curved or the sloped length of this is that links to this radius here. So when we're asked to figure out this angle X, we got a lot of steps to take in this first, as indicated by the fact that this question is out of 6 marks. So the first things first, the volume of a cone, we're going to be using that formula because they've given us that piece of information. A third pi r squared h is the formula for the volume of a cone. Our volume is 1,600. Our radius we do not know, and our height is 25. We can simplify the right hand side there, which will give us a 25 pi over 3, and that is getting multiplied by r squared. What we can then do is divide both sides by that 25 pi over 3 to get the r squared on its own. If we do that, we're going to get a value of r squared equal to 61.115 and change. And if we square root both sides there, we get a radius value of 7.8176 and change. So that's just got our radius for the circle here. So that is 7.8 and change. What comes next is figuring out this sloped length L. We have our height, we have our radius, and these two along with L create a right angled triangle. So in order to get L, we're going to do Pythagoras. So L squared is going to equal 25 squared plus 7.8176 and change squared, making sure we use our answer button here. L squared will then equal 686.11 and change. To get L, we're going to do the square root of that number. And from there, our value of L is going to be 26.193 and change centimeters. So we now have this length 26.193 and change, which is the radius of this sector here. I'm using capital R because of the fact that this radius is not the same as the radius in the cone below. And the only other thing that we need now in order to figure out the size of this angle is we need to know what the length of this arc AB is, which means we need to know what the circumference of that circle AB is here. So circumference equals 2 pi r. The reason I'm using 2 pi r is because of the fact that our radius value here is given. We need to double it and then times it by pi. So 2 times pi times this 7.8176 and change, that is going to give us a circumference of 49.119 and change. So this arc length here is, I've forgotten already, 49.119 and change. We have our radius here as being 26.193, and we're looking for the angle X, like so. So cast your minds back to when you are dealing with arc lengths. Finding the length of an arc from a sector was found by taking whatever angle you were given in the sector, writing it out of 360, in other words, to figure out what fraction of the circle you had, what fraction of the total circle there you had, and then we would multiply that by the actual circumference itself, which would be 2 pi r in this case. Now, r isn't little r in this instance, it's the capital R that we have figured out the radius of, like so. And our arc length is what's in red is our 49.119. So just utilizing the space that I have up here so I can keep the picture on the screen, we have 49.119 and change is going to equal our angle theta is x in this case. So I'm going to have x over 360. That's going to be multiplied by a 2 and a pi and the value of capital R, which is 26.193 and change. What I'm going to do now is, because x is what I'm looking for, I'm just going to do all of the sums here on the right hand side, which is basically a 2 times a pi times this 26 and change, and then divide all that by x. When I do that, I get the value 0.45715 and change. So we have that times x. On the right hand side, we still have this 49.119. And then in order to get x by itself, I'm going to take that 49.119 and change, and I'm going to divide it by 0.45715. And when all is said and done, our x value is going to turn into 107.44 and change, which, when we round it to the nearest whole number, is going to give us 107 degrees. So 107 degrees is our final answer there. Done.